Last time we started working in surface area, we had talked about rectangular prisms and cubes, and we had just done the surface area formula for a cylinder. That's where we left off. The surface area formula for a cylinder was this one, where we had 2 pi r squared. Those were the top base and the bottom base. And then we had the 2 pi rh, which was the rectangle that's actually around the side of the soup can or the soda can or whatever, but the cylinder. And here's our first example for today. A soup can has diameter 2 5/8 inches and a height of 4 inches. What is the area of the paper needed for the can's label if the label is to cover the entire lateral surface area? You need to be a little bit careful because it asked you for something very specific. What type of area did it ask you for? The lateral area. So if you use this entire formula here, you will not be answering the question that it asked, right? Because the soup can's label is not on the top and the bottom of the soup can. It's only around the edge. So in terms of this equation, it's asking you for this part, right? This part is the lateral area. We're asked to find 2 pi rh. So our lateral area, 2 pi rh, is what we're looking for. Now, R and H, you were given one of them specifically, straight out. Which one were you given? H, the height. What was the height? 4. You weren't exactly given the radius, but you should be able to find it based on what you were given. What were you given that will allow you to find the radius? Yeah, the 2 5/8, which is the diameter. So, I don't know about you, but 2 5/8 as a fraction is probably a little bit more difficult to work with than as a decimal. So if you will find 2 5/8 as a decimal, what would that be? 2.625. Say it again for me, Amy. 2.625. And if you're wanting the radius, then what would you do? You divide that by 2. So the radius would be what? 1.3. Can you go all the decimals it gives you?
Yeah, 1.3125.
125. We'll keep them all for the time being, and then at the very end we'll do our rounding. Okay? So 1.3125. Now, I've mentioned it before, but not certainly not today and not in this particular section. If you've got pi that's involved, please use the pi that's in your calculator. Don't approximate with a 22/7 or a 3.14, okay? Use the pi that you've got, the button. So go ahead and find out for us. What is 2 times pi times 1.3125 times 4? 32.99. That's what we get with 2 decimal places. And what are the units for what we just found? Inches squared, or square inches. Any questions on that one? Please read carefully, because depending on the context, they could have asked you to find surface area for this, right? They could have asked you to find the aluminum that was used in the can instead of the paper that surrounds the can, and the aluminum is on the top and the bottom. So read these questions carefully. Next one is a pyramid. In a pyramid, like in all of the rest, we've got our lateral area and we have the area of the base. The one on this is different, though, is the area of the base. There's only one base of a pyramid, right? All the other objects we've done so far had a top and a bottom, so we had twice the area of whatever the base was. Here we don't have that. And if you'll recognize, I can't remember if we've seen this happen this semester or not. I sometimes get a little bit tripped up between what I've said this time around and last time around kind of thing. But have we talked about slant height here? Not yet? Okay. So slant height is the height right here that you're seeing in the blue. It's the height along one of the lateral faces from the apex, the top, down to the base on the bottom of the side. So it is truly a slanted location. It's not the height h, which would measure from the top perpendicular to the bottom. All right? So what you see happening then is you see that we're going to find the area, in this case, of all these triangles. But the area of a triangle, you know, is 1/2 base times height, and the height that it's referencing is the height of the edge, you know, the side, which would be the slant height, L. Okay, not the height of the actual 3-dimensional object, but the height of the 2-dimensional side. So it's L that it's going to be referencing. The picture over here of the net is quite useful. Obviously, you see the base here in the middle. It's a square or a rectangle or a whatever it is. It's going to be the area of that shape, pentagon, octagon, whatever. And then you've got a number of triangles, and the number of triangles will be dependent upon the type of pyramid you're working with, right? So if it is a square pyramid, you're going to have 4 triangles because the base is a square. If it were a hexagonal pyramid, you're going to have 6 triangles because the base is a hexagon, 6 sides. All right? So let's take a look at creating sort of an equation to work with on these. Our our surface area is going to be the surface area of the base. Okay, we're using capital B for area of the base because it changes depending on the object. Plus, and then the area of a triangle is 1/2 base times height, and the height that we're talking about is this L, this slant height. And then this needs to be times n, and n is the number of triangles that we have. Now, in particular, if you multiplied the base, which would be this side length, say, right, or this side length, right, the base of the triangle, times the number of triangles, what would you actually be finding? The perimeter of the base. So an alternate version of this equation is that we could talk about taking the base plus 1/2 the perimeter times the slant height. Just another version of the formula. It doesn't matter to me in the slightest which one you use. As long as you can recognize how to work with both of them, you'll be in good shape. All right, we're going to do an example. This is an actual building. The basic shape of the Transamerica building in San Francisco is a right square pyramid that has a height of 260 meters and a square base with perimeter of 140 meters. The altitude of each triangular face is 261 meters. Find both the lateral area and the surface area for the Transamerica building. If it helps you to draw a picture, by all means, draw a picture. Here's my square base, and here's the rest of the pyramid. I can fill in some of the details that it gives me. It tells me that, let's see, it has a height of 260 meters. You need to be a little bit careful with that. What height is it measuring when it said that? The perpendicular from the apex straight down, right? So it's measuring like this. That's the 260. Change it to the same color. So the 260 is this sort of off peach color. And it's meters. And then it says the perimeter is 140 meters. So if you want to break up the perimeter into 4 side lengths, you can. Or you can simply choose to use the formula that has perimeter in it. And you can do that. So I'm going to leave it as perimeter. The perimeter is 140 meters. And then the last piece of information it gives you is the slant height, right? The slant height would actually be the other height that goes to the side of the base, like this, right? The height of a triangle. So the slant height, which would be L, is 261 meters. Okay, now asked us to find 2 quantities, the surface area and the lateral area. So let's actually find the lateral area first, because then we can use that and just simply add it to the other piece that we want. So how do you find the lateral area? What part of this formula is the lateral area? Yeah, the triangle parts, the second piece. This piece is the lateral area. 1/2 the perimeter times L. 1/2 perimeter times slant height. And we actually were given both those pieces of information. What's the perimeter? 140 meters. And what's the slant height? 261. Good job. So go ahead and multiply those quantities together. What do we get for our lateral area? 18,270 what? Yep, square meters. And then for the surface area, we will add that lateral area plus the area of the base. So the lateral area was the 18,270. How do I find the area of the base? Okay, so I'm going to need to take a look at the fact that I've got a square down here, yeah? So if I've got a square, there's my base. Oh, that was really thick. Let's try that again. A little bit smaller. There's my base. I have that same 140 and then divide by 4. So what's 140 divided by 4? 35. And then 35 times 35. What was it, Hannah?
1,225.
All right. I'm taking Hannah's word for it. Did anybody else have a problem with that? We're good with that? Okay, cool. All right, and then we're going to add those two quantities together to get our total surface area. 19,000 what?
495.
495 square meters. Beautiful. Okay, I think we have one more shape. Nope, two more shapes. I lied. All right, one more on this page. Ready? Cones. We like ice cream cones, right? But if you're going to do a cone like an ice cream cone, you can't have the ice cream piled up. We'll do the piled up cone in a minute. But right now, this ice cream cone is flat on the top, okay? All right, so we have a cone. It's the lateral area plus the area of the base, just like we've been working with these other ones. A cone is almost like a pyramid, right? It's got this lateral area, and then it's got just one base compared to the other ones which had two bases. What is the base of a cone? It's a circle, at least the standard ones we use the most, right? And remember, if you remember back on your first test, you had to create one that was non-circular. That was a struggle a little bit. So it doesn't have to be a circle, but the one we're working with most commonly is going to be a circular base. So for the case of what we're doing for a circular surface area of a circular cone, there it is, it said it there. We're going to have the lateral area and the area of the base. Let's do the area of the base first. So the area of the base is a circle. What's the area of a circle? Pi r squared. And I'm going to give you the area of the lateral area because it's a little bit weird. If we were to cut along the side and we were to lay it out flat, unfortunately, like some of these others, it doesn't become a figure that we're able to calculate very easily. It will actually still be part of a circle itself. So you're going to see part of that formula show up in it. It's actually pi r L. Okay, so it's going to be pi because you're measuring something that had a circular base. You're getting the radius because that's going to determine how far it unrolls, and then the lateral height is going to be determining how long the piece is. So if you imagine unrolling this thing, you actually end up with something that looks a lot like a pie wedge, right? That's what it would look like if you cut the side, and you've probably done it before, like a snow cone. Have you guys done that with a snow cone before where you've seen it actually rolled out flat? It'll have a shape like this, okay? So you're getting part of a pie wedge. So this is our surface area for a cone. We're going to do one more before we do our example because they're going to relate to one another. And it's a sphere. First vocabulary word here is about a great circle. A great circle is a circle on the sphere whose radius is the same as the radius of the sphere. Another way you could describe the great circle is it actually cuts it cuts the sphere into two hemispheres perfectly. All right? The intersection of the sphere and a plane through the center of the sphere. A sphere will have infinitely many congruent great circles. All you got to do is just tilt it a little bit, right? As long as it's going through the center and it's a circle, you're going to still end up giving it being a great circle. Lines of longitude are great circles. Lines of latitude are not. Okay, so lines of longitude, those are the ones that go, North Pole, South Pole kinds of things. They're not the only ones, right? But those would be those would be great circles. Latitude goes horizontally around, right? And so it doesn't have to go through the center. The one that went through the equator would, but all other lines of latitude would not work. All right, so the next formula then is for the surface area of a sphere. I'm just going to give you this one. Actually, do you guys remember this? You're really close. It's 4 pi r squared. Yeah. So the surface area, of a sphere is actually 4 pi r squared. So the pi r squared, of course, is coming from the radius of the circle, right? And then the 4 is the multiplication factor because we're looking at the top half and the bottom half to boot. And we're going to do an example that actually combines both of these, cone and sphere together. All right, because we're going to do, we can say ice cream cone, but I think probably this looks a little bit more like a snow cone, truly. So whatever image you want to say it is. You've got a half of a sphere on top, right? Hemisphere, if you will, on top. And then you've got the cone shape on bottom. And we're talking about the surface area of this particular object. Find the surface area of this cone, assuming we have a right circular cone topped by a hemisphere. So we need to find 2 pieces of information, neither of which are exactly the formulas that I already gave you. Let's talk about the cone first. The cone over here, we had lateral area and we had area of the base. The object that we are looking at, does it have both of those components that we'll be calculating? No, because the area of the base is not on the surface of this particular object. It's somehow inside of the object, right? So when we're looking at this, we're going to have to find the surface area, which will include the lateral area of the cone. I'll write it as a subscript. Lateral area for the cone. Plus. All right, so we do not have a sphere, we have a hemisphere. How is that going to be different in terms of the equation? It's going to be half of that. So we're going to have 1/2 the area of the sphere. Now, the reason I'm writing it out in words is because I don't want you to look back at this later and go, why did we use that equation? That's none of our equations. Where did it come from? If you've got it written in words, hopefully when you look back at this, you'll remember the pieces and how we came about, how they came about. All right, the lateral area of the cone. What was the formula for the lateral area of the cone? I know it's on the page before. Pi r L. I've got a 1/2. What's the area of the sphere? Four pi r squared. Okay, so let's look over here at our object now. Our object is a right circular cylinder, or right circular cone on bottom. It tells us we've got a 4 and an 8 that are labeled there. What pieces of information are we given and what do we still need to find? Okay, we've got the radius. What's the radius, Amy? 4. Amy's right. We do not have the slant height. What height are we given? The actual height of the three-dimensional object, right? So we're going to have to find the slant height. We'll do that in just a second. I'm going to leave it blank for the moment. I'll put a parenthesis here so we don't forget. The 1/2 and the 4 is going to give me 2. There's my pi. And the radius is 4 squared. So the only thing I need to find is I need to find L. How am I going to find L? Pythagorean theorem. Good job. I've got a right triangle here. I've got a right triangle that's a 4 here and an 8 here. I need to find the third side. I'll call it, oops, how about should I call it C, since it's actually in the location of where we've put C before. So I have 4 squared plus 8 squared equals C squared. What's 4 squared? 16. And 8 squared? 64. What is 16 plus 64? 80. And what will we need to do to find this? Square root. Now, I know we can get a decimal approximation, but if I keep it exact, then I don't have to worry about my decimal, so I'm just going to put square root of 80 into my equation. Fair enough? Otherwise, I want to keep a whole bunch of decimals, and that's going to take more steps in terms of typing in my calculator than this. So we're going to multiply pi times 4 times square root of 80. And we're going to add to that the multiplication of 2 times pi times 4 squared, or 16. What do we have? Is it 9.2 or 9.3? Okay. 9.3 is what I had written down. Very good. And my units? Square centimeters. Any questions on these? We're good until we get to the actual problems for homework, right? Then we'll have questions. That's great.